In page 121, number 3, we have the problem for each of the following spring mass systems. Find the displacement y as a function of time. Take g is equals to 34 feet per square second, or g is equals to 384 inches per square second, or g is equals to 980 centimeters per square second, and w is equals to 45 kilograms, k constant is equals to 9 kilogram per centimeter, y naught is equals to 0, v naught is equals to 28 centimeter per square second. So we have the solution my double prime plus ky is equals to f of x for spring. Since m is equals to the w over g, therefore the equation would be w over g y double prime plus ky is equals to 0. So dividing wg, we have y double prime plus kg all over w times y is equals to 0. So we take y is equals to e raised to the m of x. So taking the derivative of y, we have the y prime is equals to m e raised to the mx, and its second derivative would be y double prime is equals to m squared e raised to the mx. So we will solve for the value of m. M would be plus and minus the square root of kg all over w I. So the displacement y as a function of time would be y t is equals to c cosine square root of kg all over w t plus b sine square root of kg all over w times t. So we will integrate y so that we can get the velocity. So v is equals to 14v cosine 14t. We'll plug in the data. V naught is to 28 centimeter per square second, and square root of kg all over w is equals to 14. So b would be 2. Therefore, the final answer would be y in terms of t is equals to 2 sine 14t. Here in this problem, we will solve the general solution of the equation 2x squared y double prime plus 5x y prime plus y is equals to 3x plus 2. So we take y is equals to x raised to m. Taking the derivative of y prime is equals to mx raised to the m minus 1 by the virtue of chain rule. So y double prime would be m, quantity of m minus 1 times x raised to m minus 2. So plugging the data, we have x raised to m, quantity of 2m squared minus 2m plus 5m plus 1 equals to 0. Further simplification, we have 2m squared plus 3m plus 1 equals to 0. So we will take the value of m. M would be the negative 1, or m equals to negative 1 half. So yc would be c1 x raised to the negative 1 half plus c2 x raised to the negative 1. So we will solve here the yp. Yp is equals to ux y1 plus ux y2. Using variation of parameters, u1 prime y1 plus u2 prime y2 is equals to 0, and u1 prime times y prime plus u2 prime y2 prime is equals to f of x. So we will solve the Wronskian using Wronskian. So w will be negative 1 half x raised to the negative 5 halves, and w1 is equals to the negative of the quantity 3 plus 2x raised to the negative 1, and w2 would be 3x raised to 1 half plus 2x raised to the negative 1 half. So getting u1, we have the integration of w1 all over w. So u1 is equals to 8 over 5 x raised to 5 halves plus 12 over 7 x raised to 7 halves. And u2 would be the integration of w2 all over w. u2 would be the negative of the quantity of 3 halves x raised to 4 plus 4 thirds x raised to 3. So the general solution would be yc plus yp. Therefore, the equation would be a x raised to the negative 1 half plus b x to the negative 1. So don't be confused about the constant. C1 would be A and C2 would be B. Plus the YP, the U1 times x raised to the negative 1 half minus the U2 times x to the negative 1. Distributing x raised to the negative 1 half to U1 and distributing x raised to the negative 1 to the U2. So for further simplification, we have now the equation ax raised to the negative 1 half plus bx raised to the negative 1 plus 4 over 15x raised to 2 plus 3 over 14 x raised to 3. So that will be our final answer.